All right, hello, welcome to your final review videos. In this video, we're going to do number 31, 32, 33, and 34, and we're preparing for our try to final review. All right, 31 says, are the polygons similar? If they are, write a similarity statement and give the scale factor. So what we need to do is we need to figure out if our sides are proportional and if our angles are congruent. The first thing I notice is that we have this angle is 20 degrees, 120, and this angle is 120. So we are going to have congruent angles. Now we want to check our sides. Let's check out this one and this one. So I'm going to do 5 over 1.2. Now notice that's the same as this one and this one. So I don't need to worry about those two sides, but I do have to check our other ones. We want to see if this is equal to our other two sides. So 10 over 3.12. Again, that matches our second pair. So if these two pairs are equal, then we're good to go. Now if I throw this in a calculator, I do 5 divided by 1.2. This one is like 4.1667. And then if I do 10 divided by 3.12, that one is 3.205. So these two are not equal, which means that my polygons are not similar. In that case, I'm done. I don't have to do anything else, and that is my final answer. All right, number 32 says the polygons are similar, but not necessarily drawn to scale. Find the value of x and y. All right, so I know they're similar. So what that means is that I can set up two proportions or two fractions and solve for one of my missing links. So I know that if we use 16 over 12, that should be equal to x, let's change the color, x minus 1 over 6. Again, notice that my top two things are from the same shape. They're both from our first one. My bottom two are from my same shape. And then the top and the bottom are in the same spot on my shapes. I'm just going to undo a little bit. All right, so we're going to go ahead and cross multiply. So when we do that, we're going to do 16 times 6 equals 12 times x minus 1. And we are trying to solve for x. When I do that, we have 16 times 6 equals 96. And we have 12x minus 12. Again, I'm distributing my 12, so I have 12 times x, 12 times negative 1. For my next step, I'm going to go ahead and add 12 to both sides. I get 96 plus 12 gives me 108 equals 12x. I'm going to zoom out a little bit. And then my last step is to go ahead and divide both sides by 12. Divide by 12, divide by 12. When I do that, we get 108 divided by 12 equals 9. So I get x equals 9. We also have to solve for y. Now, if you've been watching my videos, I think my iPad might have updated and my app is now different. So I guess we have a blackboard instead of a whiteboard behind us, which is cool. But we have to solve for y. If you want, you can keep your first fraction the same. So you can still use 16 over 12 as your first one. So I'll do that. And that equals, and now we're going to use the parts that have y involved. So we're going to do y plus 1 divided by 21. I'm just going to section this off a little bit. I'm actually going to change that to white because apparently we have a blackboard now. All right, so we are going to go ahead and cross multiply. So I'm going to do 16 times 21 equals 12 times y plus 1. If I do 16 times 21, I get 336. So I have 336 equals 12y, because we're distributing our 12 times 1, so plus 12. Again, I'm going to go ahead and subtract 12 from both sides. 336 minus 12 gives me 324. I'm just going to move up here. So we're doing 324 equals 12y. My last step is going to be to go ahead and divide by 12. And we get y equals 324 divided by 12, 27. All right, and that is your answer. All right, 33 says the polygons are similar but not necessarily drawn to scale. Find the value of x and y. Good news, we only have an x, so we only have to do one problem. This is just like our last one. Again, we're going to put our stuff that's in the same spot together to make a fraction. So we're going to do 8 over 55. And then we're going to say that equals 4. Again, that's on the same sheet as 8, so I'm going to put it on top, divided by x. We're going to cross multiply, so I'm going to do 8 times x gives me 8x. And I'm going to do 4 times 55. If I do 4 times 55, I get 220, so I have 8x equals 220. Then my last step is to go ahead and divide by 8. And when I do that, I get 8 equals 27.5 as my final answer. Boom. Fabulous. All right, our last one says, which theorem or postulate proves the two triangles are similar? Again, your choice for this is going to be angle-angle similarity, which means you have two angles that are congruent, which means your triangles have to be similar. You could have side-angle-side similarity, or you could have side-side-side similarity. Now, what I noticed here is that, well, we have a triangle and we have some sides. The first thing I noticed is that we're talking about this big triangle, and we're talking about this little one. Now, notice I colored one part red and green. Well, I guess a few more than one parts. But mainly, I noticed that we have this angle. So I noticed right off the bat I have an angle. So my guess is we're probably not going to use side, side, side. And I would love if we could use angle, angle, because it would make our lives really easy. Now, I kind of covered up the markings, but you had this part and this part. And this hint here says use corresponding angles. Remember, these little arrows means that your lines are parallel to each other. So that means that if angles are in the same spot, they're congruent. So I know that this angle and this one correspond to each other, so they're in the same spot. So those angles have to be congruent because they're created by two pairs or by one pair of parallel lines. So I'm going to say these are similar by angle-angle similarity. Now, you could also have marked, let's use blue, these two angles as congruent. Those are also congruent, so it doesn't really matter. Technically, we have 3 angles for this one, but we only call it angle-angle similarity. All right, thank you for watching. Good luck on your final.